Biodiversity Conference. Glad to see you all here. Hope you're enjoying yourselves. Please silence your cell phones. Our next guest is internationally acclaimed author of over 150 technical papers, as well as his new book that he'll be signing outside. It's won some awards already. He'll be happy to speak with you while he's signing afterwards. He's spoken at academic conferences and congressional hearing committees for important issues ranging from roadless areas, Endangered Species Act, climate change, and a host of other important issues. He's appeared in National Geographic, Science Digest, Science Weekly, Audubon Magazine, New York Times, LA Times, CNN, MSNBC, several PBS documentaries to name a few, so we're lucky to have him. He's the president of the North American section of the Society for Conservation Biology, and the chief scientist at the GEOS Institute, as well as a fellow Italian New Yorker, and that's an important credential. He's here to talk to us today about the future of temperate and boreal rainforests. Dr. Dominick DellaSala.
Okay, since I'm Italian, I'll do a lot of hand waving, and I probably don't need a microphone. Thank you, Bobby, for inviting me here. I'm honored to be at this conference. It's so great to see so many people showing up for this conference, and the talks have been great, and I've been inspired by all the speakers that have been here, and hopefully you'll be inspired by my talk today. And I have really been privileged in the last couple of years. And way back in the 1990s, I had a thought about, boy, wouldn't it be great to have some sort of a global reference on temperate and boreal, or temperate at the time, rainforests of the world. And it took me about 10 years to kind of get the idea to a point where I could find somebody to fund the project. And in 2010, I assembled a book that I had a lot of help on. Over 30 of the world's renowned temperate and boreal rainforest ecologists worked with me on this book. And it was published in 2011 by Island Press. It got an award for academic excellence in 2012 with Choice Magazine, which evaluates academic publications every year. And since early 2011, I've been on a book tour, kind of. And it started in Ashland, my hometown, Ashland, Oregon. And then I did a bunch of trips to Alaska, Seattle, Washington, D.C., Australia, New Zealand, and I just got back from Scotland last week, just talking about the importance of these rainforests because they are relatively unrecognized or underappreciated when you think about rainforests, because most people think tropical rainforest. So I'm at the tail end of my book tour that has just been a delight to meet people from around the world that are dealing with the same problems that we are dealing with here in the Pacific Northwest. And so I'm going to give you a kind of snapshot of that. We're going to do a virtual reality tour of these rainforests. I'm going to talk about what some of the challenges are that are facing not only rainforests, but forests in general around the globe, hence the name the Anthropocene, which I'll be talking about as well. And I like to mix my science in an entertaining way. And so if everything goes well with the technology up here, and I'm very tech-heavy presentation, you'll see some music videos at the very end that if you want, you can get up and start dancing, playing air guitar, whatever it might be, because that's what I did when I first saw them. It'll be a nice way to end the talk. So hopefully you'll enjoy this, and it won't be a dull science presentation, but it'll be somewhat entertaining. Okay, so let me just begin with what motivates me. And this issue of whether or not scientists should be advocates or not was addressed yesterday in an excellent keynote that Tyrone Hayes gave. And this is something that I have been in debate circles now for several years. Should scientists be activists or advocates? And I have a international plenary that I'm putting on at the Society for Conservation Biology meetings next July, and it's going to be called, Is Activism a Four-Letter Word for Scientists? And it's because a lot of scientists are uncomfortable with the term activist or advocate, but in reality, a lot of them are doing this. It's just a different way of expressing it. And let me give you some examples. You're probably familiar with some of the people you see on the slide there, but you've got Jane Goodall, Aldo Leopold, Carl Sagan. Both he and I grew up in the same Brooklyn neighborhood, but didn't know each other at the time. Albert Einstein, Jim Hansen, Rachel Carson, E.O. Wilson. What kind of world would this be without those scientists speaking out for the issues that they represent? And so nobody challenges or questions their motives or their science. And so scientists can be on safe ground and can report the information in a way that also has policy relevance and has recommendations in terms of what the outcomes are of the way we're treating the planet. So that's where I come from in terms of my ability to do science. I do conservation informed by science. And everything I do is for this purpose. This is my 7-year-old daughter, and so the work that I do is to leave her a better planet than the one that we have and everyone in her generation. So that's my value system, and sometimes I wear it on my sleeve, and often I will present the facts and then I'll present the values that go with the facts as a conservation scientist. Okay, so now that you know who I am and where I'm coming from, let's talk a little bit about what the Anthropocene is. This is not a new term. It's been in use now for about a decade. And to begin with, if you look at human evolution in the last 10,000 years, we have been living in a climatic sweet spot. In that climatic sweet spot, the climate has been relatively stable over 10,000 years. And during that time, the Holocene period, we've had the advent of agriculture that has definitely transformed humanity. And we've had the advent of the Industrial Revolution somewhere in here. So our climate has been a driving factor in our evolution, our cultural evolution in particular. And so you can kind of see where we're headed now, the end of the screen here. Our temperatures are shooting up. Nobody knows exactly where that's going to level off, but we're out of the sweet spot. We have moved out of that sweet spot over the last several decades as a result of greenhouse gas emissions and how we are influencing the climate. And of course, the driving mechanism for this is world population growth. Way back in 1956, when I was born, somewhere here on the screen, there was 2.8 billion people on the planet. And in my lifetime, in about 50 years or so, we are now at nearly 7 billion, somewhere on the curve here, and we continue to rise. We don't know exactly where that's going to level off. Most people think it's going to level off at some point toward the end of the century with about 12 billion people. That's a lot of people. That's not enough to be sustained by the planet's ecosystems in the era of the Anthropocene. And I like this one because I like to read stories to my daughter. And you know, the little train that could is one of her favorite stories. And if you kind of see this train over there, it's pulling the world's food supply. And it's also, you could look at this as pulling our ecosystems and our ecosystem services. And it says, I think I can, I think I can. And then it gets steeper and it says, I hope I can, I really hope I can, man, I hope I can. And so I would say that we have entered the man, I hope I can part of this curve. How much more can the planet's ecosystems continue to sustain runaway population growth? That's the big question without wrecking the place. And that's, I think, our biggest challenge as we go through this period of biocultural evolution in the Anthropocene. And so here's what it used to look like if you go back to historic or even prehistoric times. During the Holocene, we were largely hunter-gatherer societies, and then we had agro societies that also came into place. So that was really kind of the interaction that humans had culturally with the landscapes. This is what we have today. The age of humanity has entered an epoch where we are a force on par with geological processes and climatic processes across the globe, hence the term Anthropocene. This is what the Anthropocene looks like today. It's a famous night shot NASA photo of Earth at night. It didn't look like this a few hundred years ago, right, in the Holocene? You do a zoom in from space looking at Spain and Western Europe, and you get an idea of the kind of footprint that we've had on the planet's ecosystems during the Anthropocene. Okay, climate is the big driver right now for a lot of changes that we're seeing on the planet. And the figure that you see here is CO2 levels in red tracking, CO2 levels in red being tracked by temperature in blue. Over the last 400,000 years, there's been a very tight association. Now look what happens during the last few decades. We're about in this area here, and we're headed up. This is where people like Jim Hansen have said is the atmospheric safety net. We really don't want to get above 1 degree centigrade of warming. That's where we are about right now. At today's CO2 levels, we're increasing at about a rate of 2 parts per million CO2 per year, and we're headed in this direction, which is moving increasingly away from the Holocene sweet spot that I talked about. And so, people like Jim Hansen are saying we need to get down to 350. That's how the whole 350.org movement started. And unfortunately, we're headed in the opposite direction. But there are some things we can do. So I bump into a lot of people that don't believe in climate change. And I know this slide is kind of old. It was the last vice presidential debates. I still can't figure out what Sarah Palin was talking about in that quote. Maybe you can, but she definitely is not a proponent of climate change planning. And in my work, I deal a lot with climate change modeling and downscaling, and you'll see some of that today. And I say to the naysayers that this is the slide that really does it for me in terms of definitive proof of global warming. So how could you deny that, right? It's definitely getting warmer out here, and so the clothing has shifted as well. I apologize to the ladies. I didn't have any men underwear equivalent that I could put up there for your behalf, but you kind of get the picture. Okay, so what is really driving these climate changes today? It's a number of factors of putting greenhouse gas emissions into the atmosphere. You can see them all here. Tropical deforestation is up there too. I don't see this pointer doing what it's supposed to, so I apologize. And cows belching all have an impact on what's going up into the planet's atmosphere. And I got my Einstein quote up there, and it kind of feeds back on what we were talking about before about the role of science in getting the information like this out. And so this bar graph shows the rate of deforestation that has happened over the last couple of decades, and you can kind of see where the hot spots are. South America is one of them, and Africa is another, and Central America, and a bit in Oceania. And I'm going to talk about North America in a minute, but you kind of break these numbers down into digestible bits. So let's start out with what the total is. We're deforesting the globe at about 32 million acres over the last decade that inventories were done. That amounts to about 88,000 acres every day, or 60 acres every minute, or over twice the size of this campus every minute of every day is deforested somewhere around the globe, mostly in the tropics. In the 3 days that I've been here, you could see over 350,000 acres. In the time it takes me to do my talk, 3,600 acres have been deforested somewhere around the globe. And when those forests are cut down, a lot of the carbon that is stored in the foliage, in the soils, and in the trees themselves goes up into the atmosphere, adding to climate change problems And it's not just the tropics. We have problems here in the United States. You can see the rate of loss of the so-called virgin forest, the old-growth forest, in different time sweeps. In addition to that, the number of roads around our national forests are degrading forest quality. There's enough roads on the national forest alone to drive around the globe 17 times. That's a lot of roads and a lot of impacts. So even though it didn't show up on that previous graph of deforestation, because of the metrics that are used by the FAO in accounting for deforestation losses, this is the kind of forest degradation that has happened in the U.S. that contributes to the same or similar problems that we see with deforestation effects. And of course, all of this feeds back on global warming. And you can see from this bar chart that forestry impacts are rated third, ahead of even all the world's transportation greenhouse gas emissions. So again, when those forests are cut down, when you do slash and burn agriculture conversion, or you disturb the soils, or you move the logs over large shipping distances, you're putting carbon upstairs. And that's adding to the climate change effects that we're seeing now across the globe and right here in our region. So the good news is that our planet is still alive with trees, and there's still an opportunity to do something about that. This is a NASA image processed for tree canopy height in different places of the globe. You see the Pacific Northwest up there in the darker green having some really high trees. And a lot of those trees are absorbing carbon. And we'll talk about that in a minute. But if you look at how much forests occur around the globe, about a third of the Earth's terrestrial surface is covered with trees. And most of those, or 40% of them, are tropical. They occur around the equatorial belt. About 30% are boreal in the northern latitudes. And then we've got about 2% that are temperate boreal rainforest, which is the subject of the book that you'll be hearing about. So even though they're a smaller portion of the global total, they are important on a global scale, as you will see in the slides that follow. So why are forests important to our own survival? Well, they are enriching the planet and providing habitat for over 80% of the world's terrestrial species. They are climate control centers of the world because of the carbon that they absorb through sequestration and then hang on to in foliage, soils, and tree trunks. They're also water purification systems, and they're important in jobs and livelihoods. So at some point, we have got to reach some sort of balance on a planetary and on a local and regional scale in terms of our sustainable use of wood products and our protection of the ecosystem services that sustain life on Earth. We're not even close to that, but hopefully you'll see in the slides later on what some steps are for getting there. So here's a quick review of the world's forests. Tropical rainforest around the equatorial belt, over half of the terrestrial species on Earth. No question about their importance. They've got a lot of public recognition over the years. Just about everybody knows about the fate of Amazonia. Boreal forest, a forest at the top of the world. You see them in Canada and Russia and the far northern latitudes. They're important for a number of reasons. Freshwater repositories. And also they are excellent at taking up carbon and hanging on to it in their soils, in peat bogs, and you've got a lot of carbon that is stored in the soils in those ecosystems that are helping to regulate the global climate. So we're going to talk in the next part of the presentation here about temperate and boreal rainforests and what they are, where they're found, and why they are important. And so when I put together the book, we identified 10 regions of the world that qualified as temperate and boreal rainforests. So the boreal rainforests are a subset of the boreal forest in general, because not all boreal forests are wet enough to be rainforests, but all boreal rainforests are part of the boreal system. And so you'll see 10 areas that are up there. I only have time today to talk about the ones that are circled, and those are the ones that I've been touring over the last 2 years. I haven't gotten to the other ones yet that aren't circled, so hopefully that'll be part 2 of the book at some point. So again, over 30 scientists were involved in this project. It was featured in the Washington Post when it first came out because it was right around the time that the United States was headed to the next round of climate change meetings in Copenhagen at the time. And we were putting pressure on the administration to make some sort of a statement about protecting U.S. forests for carbon. So when we did this, we actually used a computer model to tell us where the world's rainforests were. And we had information on climate from different places in the world that are known for their temperate rainforest characteristics. And then we asked the computer to predict the rest of the globe and where these rainforests occur. And I'm only going to show you in this talk what we're defining as rainforest, but I don't have time to get into the technicalities of the modeling that was used. You can talk to me about that later if you're interested. So here are some of the characteristics from a climatic standpoint. They're very wet places and very cool places. So you've got temperatures that range from about 52 to 64 during the warmest time of the year. There's not a lot of fluctuation in the temperature. There's a lot of, and they're also generally cool, from 4 to 12 degrees centigrade annually. Again, very wet places. Some of them have snowy winters. And here's a really important part, that these rainforests get about a quarter of their total rainfall total in the driest quarter, in the summer months. That's really critical for epiphytic lichens, which are part of the diagnostic species that occur in these rainforests all over the globe. And it's mainly because if you've got too much drying in the summertime, a lot of lichens can't tolerate that dryness. So where are they found? Well, most of them are right here along the Pacific coast of North America. We'll see some examples of this. Those are percentages that you see on the bars. And then Europe has a bunch, but hardly any of them are intact. They're fragments, they're relics all over the place in Europe. You'll see some of this later on. Chile and Argentina, Australasia, and so on. Why are they important? So here's the part of the talk that even though they represent only about 2% of the world's forests, they are indeed working forests from the standpoint of ecosystem services that they provide, particularly cleansing the air that we breathe, which is just phenomenal that an acre of rainforest in our region has over 1 billion needles, and those needles are just kind of soaking up the atmospheric particulates that we're throwing up in our automobiles and our use of fossil fuels, so they're helping to cleanse that air that we're breathing. The lichens are the kind of barometers of good air quality. When I went over to Europe, there were less lichens because of the air pollution in the European rainforest. And over here, we've got a tendency to have cleaner air and much richer lichen communities. In fact, our lichen diversity in the rainforest of the Pacific Northwest is higher than the world's tropical rainforests. There was one site in BC, Canada, where over 750 lichen species were identified in a single stand of trees, which is amazing in terms of lichen richness, because this is really lichen, high-quality lichen climate and good habitat in those old-growth rainforests. Again, they purify our drinking water. You cut down these forests and you get sediment pollution into the streams, and you have to start shipping that sediment out of your reservoirs if you don't have the soils anchored. There have been studies in New York watersheds that have showed that it's far less costly to protect the watershed than to either build a reservoir to store the water or pull sediment out of the existing reservoirs. So that led to a lot of conservation in New York State when they were able to quantify that ecosystem service benefit that the forests were providing to the surrounding communities for free. Another area that is really emerging as important is the issue of carbon sequestration and storage of carbon in these ecosystems. You'll be hearing a lot more about that in my talk. And basically, these trees go through photosynthesis. They take CO2 in, and they hold on to a bunch of it in their tree trunks, which allows them to grow over time because they're making sugars and food. And as the plant ages, it basically looks like a big stick of carbon. And so you're going to see some of these sticks of carbon as we go through the ecosystems of interest. And when you start tallying up the carbon in these forests, they come out as significant on a global scale. And this is kind of a back of the napkin tally of carbon using different estimates from around the globe. And if you add it up and you make the equivalents to carbon dioxide, that is a greenhouse gas, the rainforest that we're talking about are storing over 6 times the equivalent of greenhouse gas emissions that we're putting up into the atmosphere. So if we cut those forests down, we will definitely increase global warming problems because of how much carbon they are hanging on to in their foliage, soils, and trees. And if you zoom into the United States, this is a mapping project that is underway now at my organization where we're identifying and mapping the most carbon-dense forest in the United States. You see that on the screen in green. Notice the high concentration of carbon-rich forest in the western United States, and many of those are coastal rainforests, especially along the Cascades and along the Coast Range. High concentration of very carbon-rich forest in those regions. So when I was putting together this book, I had the opportunity to be hoisted above the rainforest canopy at the Canopy Crane facility in Washington State on the Columbia River just east of Portland. You get kind of put up in this bucket. There's a lot of monitoring that's going up there in the canopy on canopy species, on carbon flux in these ecosystems. It's a really cool project that's been going on for many years. You get up in these canopies, it's kind of a weird feeling because you're looking down into the trees. And I've never had that experience before. I've always been looking up. But that's where a lot of the ecosystem diversity is. It's in the canopy. And when I first did the book, NPR was talking to me. They said, we need sound. You've got to have some sound for this interview. And I thought about it, and I've been in the tropical rainforest where I couldn't sleep at night. It was just so alive with sound. So much going on in tropical rainforest. And then I go up into the temperate rainforest, and it's quiet. You can hear crickets. And a lot of it is because it's above us and it's below us. It's in the soils. It's in the canopy. And as we look more and more into these tree canopies, we're finding exceptional richness, like in the epiphytic lichen communities that are just more rich than even the tropical rainforests. Okay, so now here's your virtual reality tour. We're going to go around the globe and see these 4 or 5 areas with some examples of what they look like. We're going to start right here in our backyards, the Alaska to Redwoods region, the North Pacific coastal rainforests. The Tongass old-growth forest is where I cut my intellectual teeth. Back in the 1990s, I was doing bird surveys, wolf surveys, deer surveys in clear cuts and old-growth forests, pondering why I was documenting the demise of these rainforests. But nevertheless, being up there was a learning experience for me personally because I got acquainted with some of the uniqueness of place. And in the context of the Tongass rainforest, it's globally significant for a number of reasons. I'm sorry, jumped ahead there. Not the last of which, it's one of the most productive salmon rainforests on the planet. In fact, it's arguably the most productive salmon rainforest on the planet. The Canadians like to think of the Great Bear Rainforest right up there with the Tongass. I'm not going to argue it. Both of them are really important from a salmon standpoint. Salmon are driving food web dynamics up there. Even wolves feed on salmon in this rainforest. That's how incredibly super productive it is. I'm going to jump out of this slide, and hopefully the technology will work. But if it doesn't, I also put up the time series that you see there. This is Prince of Wales Island, where I did my research in the 1990s, looking at different time slices of roads and clear cuts in the different colors. And you get kind of a better feel for it if you jump out of the slide and you click on this time series. Let's see if it'll work. It worked in practice. And it's taking too long for some reason. Okay, come on back. Okay, there it is. Don't you just love those messages? Okay, we'll try it one more time. There we go. Okay, Prince of Wales Island in southeast Alaska, third largest island in North America, rainforest, 1960s, 1970s, 1980s, 1990s, 2000. So hemorrhaging of one of the most important coastal rainforests in the world, because that's where a lot of the really big old growth trees are, or were, on Prince of Wales Island, which is why I was up there doing my research, which is why this is still a center of conservation attention, because of the amount of cutting that's happened up there over the course of about 4 or 5 decades. And so some of the thinking that's emerging now from this is, can we look at these ecosystems from the standpoint of their ecosystem service values? If you start to look at the Tongass, it emerges as a carbon champion. About 8% of the total carbon in the United States is represented in that rainforest. A lot of carbon is tied up there, and if you do the math and convert that carbon into carbon dioxide equivalents, those forests are holding on to about 200 times Alaska's annual GHG, or greenhouse gas emissions. And so what we have been doing is encouraging the Forest Service to transition out of the business of old growth logging and into the business of restoration. There's some interest in the Forest Service in doing this. The problem is they think it's going to take 30 or 40 years to get to the point where they could make the jump into second growth management. We want them to make the jump sooner, not later. And so there are different ways to get at this. One way is to put a value on carbon, particularly on the private lands, that could be set aside as a way to hang on the carbon, old growth carbon, to at least slow the rate of logging on private lands in that region. And it's some of the work that my organization is currently involved in. The other way that we're looking at advancing conservation on the Tongass is through this Salmon Initiative that is being run by Trout Unlimited and the Audubon Alaska folks in partnership with commercial fishing groups. They are getting pretty close to introducing broadly supported legislation that would protect about 2 million acres of really important salmon intact watersheds, and many of those have old growth forest in them. And so even with all the cutting that's been happening on the Tongass, which has slowed over the last decade or so, there's still some potential for big conservation gains up there. You know, here's another region just to the south. You can see that little square bar there that shows the area of interest. Canada's Great Bear Rainforest, which is also globally unique in terms of having 1/4 of the world's temperate rainforest. And a lot of that is still old growth temperate rainforest, absorbing a lot of carbon dioxide from the atmosphere. This again is a salmon-driven rainforest. Bears, wolves, eagles, just about any kind of vertebrate that can get around in the streamside areas is eating salmon carcasses. Even the trees are eating salmon carcasses. In molecular investigation of what's in these trees has shown the same nutrients are in the trees that are in the salmon carcasses. So the trees have been absorbing those nutrients. The nutrients get carried around the riparian zone. Some of them work their way up the uplands. They get carried by bears and wolves, and they become fertilizer for these ecosystems. So it's a real tight relationship there between the terrestrial and the freshwater that's linked by iconic salmon. There's a very interesting rare white phase of a black bear, which is called the Kermode bear or the spirit bear. That's got a very restricted distribution in the BC rainforest, and it's also impacted by logging. Roads and clear cuts don't go well with the spirit bear in the Canadian rainforest. And so really interesting and cool things have been happening in this rainforest. The conservation groups had a bold vision. They said, we want, based on scientific assessments that have been done by scientists in the region, we want 70% of this area in some form of protection. They started out in 2005 with only, I think it was 7 or 8% protected. They're up to 50%, and they're inching toward the 70% recommendation by the scientific community. Now, albeit the BC government has stalled in implementing this agreement, but it is historic in the sense that First Nations were involved, conservation groups, scientists, and the timber industry were involved in structuring this agreement that has support at the level of the government, but is yet to be fully implemented. So there's some work that needs to be done there, but it's a bold vision, and it has legs. So we're moving further south now into closer to home, the Olympics to the Redwoods. They're doing their work, uptaking CO2, hanging on to it for long periods, and you can see the equivalent of the amount of carbon that is stored in these rainforests is about twice the nation's annual emissions of greenhouse gases. So we don't want to cut those forests down because a lot of that carbon would wind up in the atmosphere, making global warming even worse. Okay, so this is another cool graphic that I'm going to show you here, and it's closer to home. It's in Southern Oregon. It's provided by Sightline Institute. They did some mapping of clear cutting in the region going back to 1970 and progressing to about 2002 that I'm going to be showing you here. And you know, within my lifetime, this this area has been greatly transformed. So back in 1970, I had an afro, and the forests were a lot more intact. And so you'll see in the different color shades, the red are the really young clear cuts, and as we go through time, the colors will go more towards yellow as the clear cuts are aging. But you're going to see what the level of impact has been here as we progress it over time. It got stuck. Okay, well, you would have seen a shotgun blast of clear cuts on this screen that has just eaten its way across the region with only a few areas left that are still relatively intact. And the interesting thing about it is if you look at the harvest statistics that have been in the area now for the last 3 or 4 decades, notice what happened here. So in the 1980s, we had a boom in the logging in this region, and then it hits this point. Northwest Forest Plan kicks in. If this didn't kick in, right about now, we would have had all of the old growth forests in our region, except in wilderness areas and remote areas, would have been logged. So that has been the benefit of having the Northwest Forest Plan in place and why conservation groups continue to work on maintaining the integrity of the Northwest Forest Plan. Okay, now I'm going to talk about the elephant in the room, the chaotic Anthropocene climate that we have initiated. You're going to see a lot of different climate projections. I don't want to focus too much on the different climate models that you see up there, but as I mentioned, I spent a lot of my time looking at climate models and climate projections. And this one shows for the whole Pacific coastal rainforest region a warming by the end of the century of 2 to 6 degrees. You know, roughly just double it to get to Fahrenheit, okay? And you can see in dark red, the interior portion of Alaska really heats up. The whole place heats up. Even the blue shade is warming. But in general, the northern latitudes get hit the hardest in a warming world. And that's going to have implications. Also, in this chaotic Anthropocene climate, we have changes in precipitation. And these three models show an increase in precipitation in the northern latitudes. That's what these color shifts are here. My pointer's not working well. There we go. All three models show that. One of the three shows a reduction or a drying in the region south of Vancouver Island. And so it could get drier down here over the course of the century. And later on, if you're interested in how we deal with this kind of uncertainty, I could talk about it. But right now, just take my word for it that northern latitudes get wetter. There's uncertainty as you go south, but it could get drier down here. So what does this mean for rainforest vegetation? This is a series of model projections looking at rainforest assemblages and how they may respond to the same climate shifts that you saw in the previous slides. The paper's in review right now in conservation biology, but I'll show you some of the preliminary results. Don't pay too much attention to all the different colors because I don't have time to go through it. But basically what this is projecting is the BC coastline, deciduous trees start to expand. The climate gets more favorable for deciduous trees over conifers in several places, and the Kenai Peninsula of Alaska goes from a needle-leaf forest increasingly toward a mixture of different conifer species that have different tolerances for the climate shifts that are happening. So there are vegetation changes likely to be associated with these climate changes that are happening. You get to the southern terminus down here. The basic take-home message here is, oh, you can see my pointer, great, is the Redwood Zone in the southern part of the Redwoods increasingly shifts to subtropical woodland types. And so this has implications for how we do conservation in this region. This is a publication that just came out in the Natural Areas Journal that I was involved with that identified potential microrefugia in the Klamath-Siskiyou region. Don't worry too much about the colors you see up there, but the take-home message of that paper is these are areas that have characteristics likely to maintain moist environments as the surroundings dry up. So we're looking at protecting north-facing slopes, the bottomland areas, old-growth forests, areas of relatively high precipitation. So when you do reserve design, you need to start looking at the areas that are likely to present microclimatic features for maintaining the existing biodiversity in this region. You get to the redwoods. The redwoods are a very troubling place because we've already seen a decline in this region in coastal fog over the last 3 or 4 decades. On top of that, the climate models project nearly the entire climate niche of redwood is lost by the end of the century. So what redwood likes in temperature and precipitation goes away by the end of the century. That's what these projections show. And so what we're recommending is this kind of a reserve design for redwoods, which would be, okay, so here this little insert here shows the, in orange, the current climate niche of redwood, and in blue, it shows how the climate niche is likely to appear to redwoods by the end of the century. So you can see the extent of the loss of the climate niche of redwood. The bigger slide here shows the area in green are intact redwoods that will remain relatively stable from a climate standpoint. The areas in blue are fragmented redwoods with a relatively stable climate in the region. So the thinking is connect the dots, allow a more permeable landscape for redwood assemblages to move around into stable microclimatic regions or areas while the climate around them shifts. Okay, so about 3 or 4 years ago, when I was doing research leading up to the book, I had the opportunity to go down to the Chilean Valdivian rainforest in the southern hemisphere, which was another extraordinary experience. And I felt like I was in Alaska, but everything got kind of flipped upside down. So there were glaciers down there. There were, rainforest trees that looked a lot like the trees I'm familiar with here, like a lierse looked like a redwood. And so there were a lot of similarities. The topography looked very similar. It's a really neat place. If you haven't been to it, I highly recommend it, because the species there have ancient origins. The place was all connected, over 200 million years ago through the supercontinents. And so what we see today are those little blotches on the bottom in red are different genera of tree species that are shared across vast differences. Like the Notophagus genus occurs in those red areas. And the reason why it occurs in those areas is because everything was connected at one point. And as the continents separated and you had continental drift, you've got similar species showing up in vastly different parts of the globe. Pretty cool to have that kind of origin or connection to the past going back to the time of dinosaurs. And a lot of these species look like dinosaur remnants, like the monkey puzzle tree that you see on that slide there. It looks prehistoric. It's really a beautiful landscape, influenced by a lot of natural disturbance processes, and they have ancient forests just like we do. So here's the kicker with this region, why it's of global importance. Most of its vertebrate species are endemic, and many of them are global endemics, found nowhere else on the planet. You can see the levels of endemicity of the different taxa, and we're really concerned about endemic species, especially those with narrow ranges or range-constricted endemics, because if a meteor happens to hit their one population, that's it. They're gone. So even small disturbances to endemics with narrow distributions could be catastrophic, and many of these endemic species are of great conservation concern and have declined in the Chilean rainforest. You also have a mixing of these different affinities, both neotropical and Gondwana biota that occur in that area. And they've got their old growth dependent species like the rufous-legged owl that you see on the slide and the Magellanic woodpecker that you see on the slide. They are also, with their controversial logging projects up there, that big tree that you see with somebody hugging it is an Alerce, which looks a lot like a redwood. It can live for over 3,000 years. Alerce is a CITES-listed species. It's protected by the Trade in Endangered Species Products globally. And unfortunately, a mayor in Chile was involved in illegal trafficking of Alerce into the United States. And fortunately, that mayor, who's no longer the mayor of his community, was indicted in Chile's Supreme Court. Unfortunately, the U.S. connection in that illegal trafficking has not been prosecuted. And so it just kind of illustrates the trade in timber products across vast regions. And so our consumption here in the U.S. impacts rainforests, in the southern hemisphere. And I'm sure you all know the story about how we're impacting tropical rainforest deforestation, but I'll bet a lot of folks didn't know that it's also happening in places in the temperate world. I also was able to visit the rainforest in Australia and New Zealand, and that's a place where size really comes into place. The tallest flowering trees in the world, the Eucalyptus regnans, occur in that area. Historic estimates on those trees were 550 to 600 feet tall. So when I see when I go into the redwoods, as much as I love redwoods, and I see tallest tree on Earth, I'll bet they didn't go to the eucalyptus rainforest in Tasmania when they made that estimate, because Even though it's a flowering plant, it's an angiosperm, it really, it's remarkable that a tree like this can grow almost to 600 feet. Tallest living eagle in the world, and tallest freshwater crustacean in the world as well, or biggest, not tallest, but biggest. So a lot of big things in Australia, and their rainforests also are doing their work of absorbing a lot of the emissions coming from Australia, which is pretty cool now because the Australian government is starting to warm up to the idea of they've got a cash crop out there. If they don't log their forest, they could be making somewhere in the way of anywhere around $3 billion in carbon cash if Australia commits to the Kyoto Forest Protocols. So they're starting to pay attention to this. So when I was in New Zealand, just kind of skipping over, I happened to visit the giant kauri rainforest. And again, I thought redwoods were the biggest trees I had ever seen. This is the widest tree that I ever saw before. And it's hard to get this from the screen, but you could park 2 school buses side to side and hide them behind this tree. It was massive. And this rainforest once existed before the Maoris and before European deforestation. There was about 4 million acres of it. Now there's only about 300 acres. 4 million acres, 300 acres that are left because of deforestation. However, I'm sorry I'm jumping back now to Australia, but Tasmania, the good news is Tasmania just reached an amazing agreement to stop logging their native forests. And they're in the process now of setting up high conservation value forest reserves that are being designated through scientific and consensus building processes. They have agreed to guarantee a certain flow of wood products coming from their plantations. They're also investing in retraining and employee assistance programs and economic diversification in rural communities. So about $250, $260 million is going into this transition. That's happening in Tasmania right now to get them off of logging their native forests. And the reason why this is happening is because a lot of the conservation attention that was directed in that region from Rainforest Action Network and the Australian, the Wilderness Society of Australia has been involved in this, and they got a local mill to shut down because of the international pressure that was exerted on this mill that was taking those giant eucalyptus trees and grinding them up into wood chips for people's gardens. So that global attention led to those agreements that you saw in the previous slides. Okay, my last example, which I just came from last month in Europe, which really is an example of the Anthropocene big time for those of you that have been on the European continent. They do have rainforests, believe it or not. They have maritime climates, and they climatically qualify as rainforest using the definitions in our book, but they don't look like rainforest, and you'll see that in some of the slides that I'm going to show you. And you can see it geographically, different places in Europe that have rainforests, Western Europe, in this region here, and in Central Europe. I'm only going to focus on a couple of examples, mainly Norway, because it's the highest latitude boreal rainforest in the world. They occur up to perhaps 71 degrees north latitude, which is really up there in terms of having trees. They get enough precipitation to qualify for rainforest. They are lichen rich, but you can see not much of that forest has been protected. And we'll talk a little bit about how you do conservation in the Anthropocene when most of the landscape is culturally defined, like in Europe. I happened to visit this rainforest, and you're probably scratching your head, how could that be a rainforest? It is. It gets enough rainfall, it qualifies climatically, and it's a unique hazel woodland environment. The trees that you see in that slide, anybody want to guess how old they are? Just take a guess. Not very old or very old? I gave it away. They don't look very old, right? But these trees grow in a stool-like arrangement. And the stools are commonly organized in a circle. All of the stools are genetically related to their neighboring stool. And those stools can trace their ancestry back 8,000 years ago. So it changed my perception of an ancient forest. It doesn't look like an ancient forest. It doesn't even look like a forest, but genetically related for 8,000 years on the same site and loaded with lichens. Most of the lichenologists that I was with on this field trip didn't move more than from 1 to 2 stools. They had a hand lens out the whole time. They were looking at the world of the rainforest through a hand lens, which is another thing that I wasn't used to. So the difference in this Anthropocene landscape is, at one point during the Roman Empire, about 90% of Europe was forested. And you can see that's been flipped. So now, almost all of Europe's primary forests have been deforested over centuries of cultural modifications on the landscape. But all is not lost. Anthropocene conservation in Europe has involved rewilding landscapes. Scotland is involved in a bold initiative to increase its forest cover, although it's being debated about what they're planting with. A lot of the trees that they're planting are lodgepole pine and Sitka spruce, which we don't want to see because, it's the commercial value versus, the carbon and the ecological values. And there's also a big effort to rewild those landscapes and bring back a lot of the charismatic megafauna. And I talked to a lot of groups in Europe that are doing this now. There's a big push in Europe to protect their low-density roaded areas. They're calling them roadless, but I like to call them low-density because there aren't that many that are true roadless, but they have ecological values. And so I kind of put this together at the end of my talk. I hate the Homeland Security Advisory System. It's always the same color. But I actually have broken down the colors, and you can see the different threat levels for these forests around the globe, kind of a synopsis of where we stand in the Redwoods and where some of those other areas stand in terms of the threat levels and what needs to be done to sustain them. And so getting back to how I opened the presentation with my daughter in the slide, and someday she's going to be my age, and this could be on the front page of the newspaper for Earth Day in 2050, which is a very pessimistic message, or she could be reading this. And so getting to the optimistic version of this requires stepped up conservation in the Anthropocene, including a 12-step program for sustainable forest management. I just published this in Conservation Biology this May online. Here are some of the ingredients: different markets campaigns, particularly those run by Forest Ethics, are transforming companies and their purchasing supply, preparing for climate change. A lot of this is happening now at the grassroots level. There was Nicholas Stern, the famous global economist, estimated that if we put 2% of the global GDP into investments for climate mitigation and adaptation, it'll avoid 20% losses in GDP by the middle of the century. Invest now while it's cheaper. There's all kinds of interest in carbon and whether or not the carbon market really catches on. The UN was asking for anywhere between $17 and $33 billion of investments to slow deforestation by a half so that we can stay within 2 degrees centigrade warming. So a lot more money needs to be put into that. And then, closer to home, protecting these stable climate areas and connecting them on the landscape. Thinking Bold for Conservation. This is an article I was involved in, again, in conservation biology that Reed Noss led, that shows on one axis, or side of the axis, here are political targets for conservation, and here's what the scientists are saying. And so in this article, we said that we really need to think bold, because it too often winds up being driven by political processes that aren't protecting enough of these regions. There are success stories that we talked about where this has happened, thinking big, Tasmania, British Columbia, the Great Bear, and even the Northwest Forest Plan to a certain extent. Okay, so here's the fun part of my talk. So I have 2 closing music videos that hopefully will get you motivated on some of the things that I've been talking about. So it's going to take me a little bit to set it up, so bear with me. Hopefully this will work. If it doesn't, I have backup. Okay, we're going to skip this and go to the backup. I thought I had the backup, and I'm not even seeing that. I'm not familiar with, well, let's try it one more time. Okay, I'm going to go just to the one that I know that works. Okay, before I start this program, I want to tell you why this is up here. So, the year was 1989, and so I'm in my hotel waiting to transfer planes to go up to the Alaska rainforest to, as I mentioned, document the demise of these giant Sitka spruce rainforests and thinking about the meaning of life. Why am I doing this as a biologist and not getting through to folks about the importance of this place? And so I happened to flip on the TV, and at the time MTV was really big. I don't know if it's still big now because I don't watch TV anymore. But I happened to flip on MTV, and this music video came up. And this video changed my life, because after I saw this, I knew what I wanted to do. And shortly after that, I was hired by the World Wildlife Fund to start their temperate forest program, because that was the bridge for me to bring science to policy. And then in 2006, I co-founded the GEOS Institute, and the rest is history. The book came up, so on. So the video is by Bruce Coburn, and for me to obtain the rights to show this video, I had to purchase 100 copies of his double live CD from his publisher. And I sent him 2 books, but I never got anything in return. So I'm selling, in addition to the books in the background, I have some Bruce Coburn CDs that are left. I only have 4 left. I've sold almost all the 100 that allows me to show this video. And someday I hope to meet Bruce Coburn so I can thank him for inspiring me. And actually, if you get the book, you'll see in the preface, I quote his song. And so this is the song that really kind of launched my career in rainforests.
Rainforest, mist and mystery, teeming green. Green brain facing the bottom. Climate control center for the world. Ancient cord coexistence hacked by parasitic greedhead scam. From Sarawak to Amazonas, Costa Rica to mangy BC hills, Cortez rhythm of falling timber. What kind of currency grows in these new deserts, these brand new floodplains? take out trees, take out wildlife at a rate of a species every single day. Take out people who've lived with this for 100,000 years. Inject 1 billion burgers worth of beef. Grain eaters. Methane dispensers. Through thinning ozone, waves fall on wrinkled earth. Gravity, light, ancient refuse of stars. Speak of a drowning. But this is something other. Busy monster eats dark holes in the spirit world, where wild things have to go to disappear forever.